Imagine you're sitting in a classroom bench with your friends. Everyone is tightly packed. Suddenly, one student gets up and leaves. What happens next? The others immediately adjust and spread out to gain stability and comfort. That is exactly how the E1 reaction mechanism works. In an E1 reaction, the first step is when the leaving group leaves the molecule, just like that student leaving the bench. This creates a carbocation, which is unstable because it now has empty space and less stability. Then, in the second step, a base removes a nearby hydrogen atom. The electrons from that bond shift to form a double bond, helping the molecule adjust and become more stable, just like the student spreading out on the bench. Let us see E1 reaction and mechanism. E1 reaction stands for unimolecular elimination reaction. In this reaction, a molecule loses a leaving group and a hydrogen atom from beta carbon to form an alkene. The reaction is called unimolecular because the rate of reaction depends only on one molecule, that is, substrate. The rate law is rate equals to K into substrate. Even reactions usually occur with tertiary alkyl halides or alcohols in the presence of weak bases and polar protic solvents like water or alcohol. The mechanism takes place in two steps. Step 1. Formation of carbocation. The leaving group departs, taking its bonding electrons with it. This forms a positively charged carbon intermediate called a carbocation. Because this step relies on the breaking of a single bond, it is slow and determines the overall speed of the reaction. Step 2. Removal of beta hydrogen. A weak base such as water removes a hydrogen atom from the carbon adjacent to the positively charged carbon. This hydrogen is called the beta hydrogen. The electrons of the CH bond move to form a double bond between the two carbon atoms. Finally, an alkene called 2-methylpropene is formed. Let me explain E1 reaction in detail. E1 reaction is favored by tertiary and secondary alkyl halides, whereas primary alkyl halides do not favor E1 mechanism due to instability of primary carbocation. E1 similar to SN1 in formation of carbocation, but second step varies here. In E2, second step is abstraction of proton from beta carbon to form alkene. 1-bromobutane is a primary alkyl halide. In an E1 reaction, the first step is the removal of the leaving group, Br- to form a carbocation. When bromine leaves from 1-bromobutane, a primary carbocation is formed. Primary carbocations are highly unstable because they have very little electron donation from neighboring alkyl groups. Due to this instability, 1-bromobutane generally does not undergo the E1 mechanism. Therefore, E1 elimination is extremely difficult and unfavorable for 1-bromobutane. 2-bromobutane is a secondary alkyl halide, so it can undergo the E1 mechanism more easily. In the first slow step, bromine leaves and forms a secondary carbocation. This carbocation is more stable than a primary carbocation because adjacent alkyl groups donate electrons through the plus I effect and hyperconjugation. In the second step, a weak base or solvent removes a beta hydrogen from a neighboring carbon, producing an alkene. Similarly, tertiary alkyl halides also undergo E1 mechanism to form alkenes. Next, we will see E2 reaction and mechanism. In the E2 reaction mechanism, the reaction happens in a single concerted step, where the base removes a beta hydrogen. At the same time, the leaving group departs from the alpha carbon, forming a double bond instantly. E2 is like an archer pulling a bowstring. The base pulls the beta hydrogen like drawing the arrow back, and the leaving group shoots out simultaneously, creating the double bond. Here, the alpha carbon is the carbon attached to the leaving group, while the adjacent carbon is the beta carbon containing the beta hydrogen. As the strong base attacks the beta hydrogen, the electrons from the CH bond move to form a pi bond between the alpha and beta carbons, while the leaving group leaves at the same moment. Since everything occurs together in one step, E2 reactions are fast and do not form carbocations. The product formed depends on which beta hydrogen is removed. Small bases usually give the more substituted Sadzef product, whereas bulky bases prefer the less hindered hydrogen and give the Hofmann product. In the E2 reaction mechanism, elimination occurs in a single step when a strong base removes a beta hydrogen from the beta carbon, while the leaving group simultaneously leaves from the alpha carbon, forming a double bond instantly. In 1-bromobutane, the carbon attached to bromine is the alpha carbon, and the adjacent carbon is the beta carbon. When a strong base attacks a beta hydrogen, the electrons from the CH bond form a double bond between the alpha and beta carbons, and bromide leaves at the same time. Since there is only one beta carbon available, only one alkene forms, but-1-ene. In 2-bromobutane, the carbon attached to bromine is the alpha carbon, and there are two beta carbons on either side containing beta hydrogens. The base can remove hydrogen from either beta carbon. Removal from the less substituted side forms but-1-ene, the Hofmann product, while removal from the more substituted side forms but-2-ene, the Sadzef product. Because but-2-ene is more substituted and more stable, it becomes the major product when small, strong bases are used. However, bulky bases prefer the less hindered beta hydrogen and mainly produce the Hofmann product. Let me explain in simple form. क्लासरूम एनालॉजी इमेजिन करो. लॉन्ग बेंच पूरी कार्बन चेन को रिप्रेजेंट करता है. बीच में जो स्टूडेंट बैठा है वो अल्फा कार्बन है जिसके पास लीविंग ग्रुप अटैच्ड होता है, और इसके दोनों साइड वाले स्टूडेंट्स बीटा कार्बन्स हैं जिन पे बीटा हाइड्रोजन्स प्रेजेंट होते हैं. अब बल्की बेस एक मोटे स्टूडेंट की तरह बिहेव करता है जो क्राउडेड बेंच के मिडिल में घुसना अवॉइड करता है. इसलिए वो इजीली एक्सेसिबल एज वाले बीटा हाइड्रोजन को पकड़ता है, यानी लेस हिंडर्ड बीटा कार्बन से हाइड्रोजन रिमूव करता है. इससे हॉफमैन प्रोडक्ट बनता है जो लेस सब्स्टिट्यूटेड एल्कीन होता है. एग्जाम्पल के लिए 2-ब्रोमोब्यूटेन में बल्की बेस लेस क्राउडेड साइड से हाइड्रोजन रिमूव करके but-1-ene बनाता है. दूसरी साइड स्मॉल बेस पतले स्टूडेंट की तरह इजीली क्राउडेड मिडिल तक पहुंच सकता है और मोर सब्स्टिट्यूटेड बीटा कार्बन से हाइड्रोजन रिमूव करता है. इससे ज्यादा स्टेबल एल्कीन बनता है जिसे सेडसेफ या जाइटसेफ प्रोडक्ट कहते हैं, जैसे but-2-ene. मतलब बल्की बेस लेस हिंडर्ड पाथ चूज करके हॉफमैन प्रोडक्ट देता है, जबकि स्मॉल बेस यूजुअली मोर सब्स्टिट्यूटेड सेडसेफ प्रोडक्ट देता है. Thanks for watching. If you enjoyed this video, please like, share, and subscribe to BRK Chemistry Academy for more chemistry concepts, shortcuts, and exam tips. Keep learning, keep growing, and stay connected with us for more exciting chemistry videos. See you in the next